Okay, so today we're going to take a look at 5.4, which is medians and altitudes. So we've skipped some sections, but we're going to pick up on some things that are fairly short definitions, and we'll have a little bit of actual math work on this, but mostly we're going to focus on definitions in 5.4. So in 5.4, we're taking a look at what are known as medians and altitudes. So just as a refresher, last time we looked at mid-segments. Mid-segments were when you connect a midpoint to another midpoint. A median is when you were taking a midpoint. So T is a midpoint, and you're going from a midpoint to the opposite vertex. So you're basically cutting your triangle into two other triangles from a midpoint to the opposite vertex. The altitude is going to be a perpendicular line segment from the vertex to the opposite side. So you're going to take a vertex and then just imagine dropping a straight line right down that connects to the other side, and it has to be perpendicular, which means you have to have this 90-degree angle. So in this triangle on the left, we have an altitude that is on the interior of our triangle. On the triangle on the right, we have an altitude that is on the exterior. So we've taken this vertex, we've made a line that goes straight down, and we have to extend this bottom side out to actually be able to connect to where that altitude would be. So this vertical line here would be your altitude because it is perpendicular to this side. You've probably actually dealt with altitudes before because when we find the area of a triangle, it is 1/2 the base times the height. And when we're talking about this height of a triangle, we're always talking about the altitude. So the height of a triangle is actually known as the altitude of a triangle. We have what is known as a perpendicular bisector. A perpendicular bisector is exactly what the words say it would be. It's perpendicular, which means it needs to be a 90-degree angle. It also is going to bisect, and bisect means to cut into two congruent parts. So if you're forming a perpendicular bisector of a triangle, you're taking one side of the triangle, you're forming a midpoint. So P would be your midpoint. It is bisecting segment AB, and it is perpendicular to that side. So perpendicular bisector is at the midpoint, and it is a 90-degree angle that's formed at that midpoint. And then finally, an angle bisector is just going to take a larger angle. Say we have angle ABC. The bisector would be segment or ray BD because it is taking the larger angle and cutting that into two smaller congruent angles. So just a quick rundown of the 4 words we've defined so far for definitions. The median goes from the midpoint to a vertex. The altitude goes from a vertex and is perpendicular to the opposite side. The angle bisector is just going to cut an angle into two congruent parts, and the perpendicular bisector is going to be perpendicular at a midpoint. So people sometimes get the altitude and the perpendicular bisector confused. The easy way to think about it, because they both have to have perpendicular, which means 90-degree angles, so it's the easiest way to pick one of those two, but the altitude has to go from a vertex, so it has to connect to one of the points of the triangle. The perpendicular bisector is going to start in the middle of one of the sides every single time. Has to be at a midpoint. Doesn't have to pass through the vertex of the triangle. So now, here we have just a whole bunch of medians of a triangle. So CE is a median, goes from vertex C to the midpoint E. AF is also a median. It's from the midpoint F to vertex A. And then we also have DB, goes from vertex B to the midpoint D. And so what we have here are a bunch of different congruent and marked sides. One of these special properties of obviously our medians is that we're getting midpoints. So let's say that if I wanted to find out what DC is, well, I already know that AD is 15, and these are marked as congruent. So DC would have to be 15 units. Well, then AC is just the full side length, and that would have to be 30. The other thing they give us is that we have this segment P, B, so from P to B is 24 units. So when all of your medians, when you form, and technically you only need to form 2 medians, but if you form 3 medians, what you find out is that all of the medians of a triangle will intersect. And where the medians intersect has a special name. It is known as the centroid. So the centroid is the intersection of medians. So when you're forming a bunch of medians in a triangle, you form what is known as the centroid. The centroid's special. The centroid is the center of gravity of a circle, or of a triangle. So what does that mean? The center of gravity. So what this means is that if you were to take a triangle, find the centroid, that is the balance point of that triangle. So you could take and put your finger right at that point, and the triangle would balance perfectly. Wouldn't fall off in one direction. You can almost think of it as, like, the example I like to think about is they have those, like, birds or whatever that have their wings kind of, flayed out or whatever. And you can balance the bird right on its nose. That's basically because the center of gravity is exactly at that point, and therefore the bird just wants to stay right there, and it'll rotate around, but it's not going to fall off. Same thing here. The centroid would be where that triangle would balance. So if you know a portion of your centroid, what happens is that we have ratios of the sides. So from D to the centroid P, this is 1/3 the measurement. And then from P to B would be 2/3 of your measurement. So that means that if you want to find out what the measurement of segment PD is, well, this is 2/3, this is 1/3, so 2/3 to 1/3, you're just dividing by 2. So if you take 24, divide that by 2, you would get that PD should be 12 units long, which would also tell you that dB, if we know that this is 12 units and this is 24, the full segment should be 36. If you wanted to double check your work, you could do 36 times 1/3. When you multiply by a fraction, you're actually dividing by this denominator, so you get 12. And then if you do 36 times 2/3, it's dividing by 3, which gives you 12, but you still have to deal with that 2 that was in the numerator, so you multiply and you get 24. So that matches the measurement there. So for the centroid, from the centroid to the vertex is 2/3. From the centroid to the midpoint is 1/3. So if they gave me the full measurement, so say they told me that dB was 60 units, if you wanted to find out what this segment would be, you would divide it by 3 and then multiply by 2. If you wanted to find out what from the midpoint to the centroid would be, that's just 1/3, so you would just divide by 3. And that really covers most of what you're going to have in this. Most of this section is actually just about identifying what is a median, what is an altitude, what is an angle bisector, and what is a perpendicular bisector.